Thank you for coming. Definitely appreciate it. My name's Tyler Yahn. I work here at Splunk. I'm a software engineer. I'm also a OpenTelemetry maintainer. I work in the OpenTelemetry space, primarily in Go. So I think you're at the right place, right? Okay. And today I'm going to talk about one of the things I am really passionate about, and that's auto-instrumentation for Go. You guys, Mihal, double check. You can hear me, right?
Yeah.
Okay, cool. Okay, so I just want to start off by maybe asking you guys a question. So is anybody in the audience an SRE? No, okay. What about DevOps? I know somebody's a DevOps. All right, it's not a shameful thing, trust me. What about just a software developer? Yeah, okay, that's kind of what I was guessing, right? So this is going to pad out your resume today because we're going to all assume the role of an SRE. We're going to try to play the game of trying to operate a service, and that service is going to be in Go. And in the process, hopefully, we're going to learn a few things. So to start out, as our operational role, we've got this new issue, right? There's this user, Alice. Alice is using our application, and she's getting a bunch of errors. She's reported an issue for us. And Alice is a pretty important user, so we want to make sure that we are supporting her, right? We're also on call, as SREs are, and we're getting a bunch of pages about errors to our application. So this is, yeah, let's see if we can track this down. Yeah, okay, it is working, perfect. Okay, cool. So this is going to be a pretty big demo application as well, so we're just going to jump up between slides, so I hope that's okay. If you need me to pause, I can also do that. So to do that, I'm also going to be looking over my shoulder a lot, so it's going to be really slow, and I apologize up front. So we can jump into the application, and let's see if we can reproduce Alice's problem, right? Maybe it's something specific to Alice. So the first step as an SRE is we're going to try to reproduce this. There's an internal error, and that might be also because the thing has crashed in the process of me trying to set up this demo. So let me just double check that we're still running, and we are. There we go. Okay, there's just a lot of errors. So we were reproducing Alice's errors. We're all good to go. So yeah, definitely able to reproduce this. And so let's back up. What is this actual product that we're actually trying to support here? Sorry, mice. And this over the shoulder thing. Perfect. Okay, cool. This is a pretty simple application, right? So as an SRE, we need to understand the role of like that application that we're running. The application is comprised of two services, a front-end service and a user service. These are isolated pieces of Go code. You can just think of them as Go binaries that are running on the server, because that's what they are. And what happens is our user, Alice, she's making a request to the service. That request is just going to respond with some random number between 1 to 6, like I was saying. A very simple service, right? Yeah, we did see this. Okay, we were able to reproduce that error, right? So now we actually want to ask this question of what's going on here, right? And to do that, we need to have some sort of way to look into our system, right? And that is important because this is where observability comes in to help us. Our unknown unknowns are going to try to be resolved in this process, right? We want to understand what's going on, and we're going to look at these different ways to look at, into our service, right? So the first way that we can do that is, luckily, the front-end team has just gone through the process of instrumenting their application and giving us some tracing. So let's take a look at that really quick. Yeah, that's a problem. To do that, we can jump into our Jaeger dashboard, and we can see if we can start querying some traces, right? So this should maybe give us some understanding what's going on in here. So if we do that, we are seeing some traces. And we can definitely see a thing called errors here. Yeah, and so I mean, like, there's some errors, right? But this is all pretty opaque, right? Like, I mean, who here has seen tracing before? Okay, a few people, right? But what does this actually mean? So let's back up, right? Let's go back here. If we go back to our pillars of observability, right? As you can see in this really snazzy diagram that I've got for you here. At the top, we're trying to get this observability, but it's held up by a bunch of different things, right? In the one case, we have traces. We have metrics. Logs are another thing that you can look at. These are all just signals. Signals are things that are going to tell you about your service, right? Tell you how the service is operating, tell you all of these things, right? So what we're looking at right now is tracing, and that's one of the pillars, right? And this is what our demo is going to be about. And so let's break down what tracing actually is, right? So tracing is comprised of spans, and these spans are the fundamental building blocks of traces. These are the things that encapsulate a particular body of work, right? So in the Go parlance, maybe that would be something like a function, or maybe a method or something like that. Some sort of operational work that is actually being done in the context of a broader executable task, right? So in this case, if we look at it, we have some sort of service A task with a really grayed out / which maybe is like a request, right? So we can kind of see that. So that's great. We know what a span is now. A span can be annotated though, and this is, I think, where the main power of these spans comes into play, because having something that tells you the execution task is a really good way to visualize maybe timing or maybe some other things. But what is going on during that is the context that we really care about, right? So in this, we know that there is actually an HTTP method. We can understand what that's going on. We understand that there's some sort of route. There's a lot of annotations or attributes that are going to be associated with these spans. And this is going to help us understand like the actual like context of what's going on. But this is really where the value of spans comes in, and that's when they start to interact with each other. Because spans are a part of what are called traces, right? And these traces are comprised of different spans in these ordered relationships. And like the relationship cannot be understated how important this is, because what we can see here is not only do we have two spans, but we know how they relate. We know that server A with this run method, which I'm sorry, can anybody see that? Okay, oh yeah, all right. I'm pessimistic while I'm giving the talk, I guess. But we can see that the server A's run method is definitely encapsulated within this main HTTP method, right? So we know that within that method, there was some sort of sub-process that came in, and it was this run process, right? This is really important. We know now that we can see the control flow of that execution through the process, and we can understand how long things are going here. And remember, all of these things have annotations, so this should have more annotations about what the context was during that time frame. So on top of that, tracing can go between services. And this is, I think, where it becomes extremely important, right? To understand the flow of information not only through a single service. If you remember, we have an application that has two services. I don't want to look at just one service, right? I want to look at what's going on throughout the entire application. To do that, I need to understand how service B, in this case, is relating to the control flow of service A. So this is going across any sort of like processing boundaries at this point. This is meaning an HTTP request or gRPC request is linking these two things. To do that, it's really important that we share context, right? Remember, context was the important thing that linked these two spans together. We need to share context across different services now. So things like the W3C trace context standard is a really important thing because it helps you routinely define how that is going to be passed across services. Okay. Is that making sense? Cool. So now, what's this big thing about OpenTelemetry, right? How many people here have heard of OpenTelemetry? I can't tell you how happy that makes me to understand that. Okay. So OpenTelemetry is a vendor-agnostic set of APIs and SDKs that are provided to a user. These tools are also provided alongside it to help instrument an application and provide all of these different pillars of observability. So one of the other beautiful things about OpenTelemetry, we were talking about the W3C standard for trace context. Another thing that OpenTelemetry provides is a set of standards. And one of the big standards is a semantic convention. So those annotations that we were looking at on a span earlier, remember those with the HTTP, all of those other attributes, right? They can show up in any form, right? Like I can call this HTTP method, in this case, HTTP dot method. I could also put an underscore there. I could just call it my cool method, right? So that's not really helpful if I'm expecting to understand like what that span should contain. I need to understand it before the span is actually generated. And OpenTelemetry helps you define that by defining those standards in things called semantic conventions. So this is a really powerful thing, and it's going to help us throughout this in understanding what to expect and what to visualize once we actually get these spans to come in. Okay, so if we take a look here, back at what we were originally looking at, which let's you know, it's a demo. Let's do it live. Let's take a look at what we just learned, right? So what we can see here is that we have a front-end service, and in that front-end service, there's some sort of top-level span. That top-level span is getting some sort of request to, it looks like some sort of endpoint, but I'm just guessing based on the span name, which is this / here, not that descriptive. But luckily, we have all these attributes, and we can definitely see that this was an HTTP method. We can also definitely see that as it comes through, it was responding with the 500. So this is the error. This is the error that we were looking at, and this is Alice's request. This is what she was having a problem with. And now we understand not only that this existed here, but we can now jump back and see the flow of that request that she made through our system. We can see that she went from our front end to some sort of roll dice method. Within that, some sort of HTTP GET was done outside of that, right? Well, this is great, right? But this is only one service, right? Like, where's that distributed tracing problem? So if we jump back here. Oh, this is scratching, isn't it? You guys didn't even tell me. I'm so sorry. Let's see if we can do something like that. Maybe that'll help a little bit. That's not what I wanted. Yeah, that is horrible. Well, Robert, I apologize for the recording on this one, but okay. Okay, let's jump back. Okay, so now we understand that was going on there, right? So jump back in. Where's the other service, right? So how do we understand like what's going on in the user service? We need to have a better understanding of that. So like I was saying at the beginning, I kind of just jumped in there, gave you a lot of words, but the front end team has already gone through and they've instrumented their application, right? So what does that actually mean? So what the front end team did is they went through and they did manual instrumentation in this particular instance. They went into their code base and they updated it. That's what it means. It's actually way more complex, trust me. Because if you can see here, there's 200 lines of code changes here, and there's a lot of actual work that they went into in the process. It's a very simple service. Like I was saying, it's just an HTTP router, essentially, right? And it took 200 lines to do a very basic instrumentation with manual instrumentation, right? That's it's a fair amount of work. It's great because they were able to give full customization. They were able to do exactly the business logic they wanted. And all of that was just like exactly, you know, it shows a very clean flow through their infrastructure, right? But we don't actually, as an SRE, have access to the production code in Go, right? It's a running binary. Like, it's not an interpreted language. It's not Python. I can't log into the server and just see like, oh, let me update this and maybe change it or something like that. I'm gonna have to go through the whole code base. I'm an SRE. I don't actually know this code base, right? Like I'm kind of lost at this point. How do I get some sort of understanding of that code base? Well, I am pretty smart in OpenTelemetry, and I know they have this concept of auto-instrumentation, right? And generically, an auto-instrumentation works like this, where you have some sort of source code. It's compiled into bytecode. That bytecode is then run on a virtual machine, and the auto-instrumentation, works run on a virtual machine. The virtual machine transcodes it into some sort of native machine code, and it's executed. The auto-instrumentation generally sits here in this step between the bytecode and the virtual machine, and it's able to understand what's going on, what's going to be executed, and it can instrument ad hoc in understanding what's actually being done on your behalf. Just a second. Oh. Sorry, that's a lack of preparation on my part. Okay. This is a room full, yeah, thank you. This is a room full of Go devs, right? Like, is this gonna work for us? Probably not, right? So Go looks very different in this world, right? Because I have source code, I run it through a compiler, and then I get this ELF or this binary, right? That binary is run directly on the kernel. There's no step here for the VM, right, to actually hook into. So how do I actually do this auto-instrumentation thing in the OpenTelemetry space? I see some hands, so I think maybe you know where I'm going. eBPF is a pretty cool technology. I swear this isn't just buzzwords that I'm throwing out at you. Has anybody heard of eBPF before? Okay, a fair amount of you, right? So eBPF is a pretty cool, it's an extended Berkeley packet filters, which actually is more confusing than what it actually is. If you can think about it, Think about it as a sandbox within the kernel that you can just run source code. You can run code that runs within the kernel. It gives you great access to things like the network, but it also gives you access to the user space. So this is a really powerful tool. It's really powerful in many different ways, and it's a very popular new technology that's being run. This is kind of cool, right? Because it's in the kernel. So maybe this can be used in that OS step that we were talking about to instrument this. And what we do in OpenTelemetry is exactly this. We combine all of these technologies together and we form this auto-instrumentation agent. So let's see what this looks like. Just gonna put it down. Robert, is there a different microphone? This is just...
like this. Here, and if we just turn it on.
Oh.
Try telling.
Yeah, that...
But I'm not try saying something.
Can you hear me? Yeah, this is 10 times better. Okay. Okay, cool. Let's do this then. Okay, so let's take a look at the auto-instrumentation. Doing some live debugging over here. So let's actually get into some code base. So cool. Let's clear that screen, make it way bigger. Okay, so we're in the auto-instrumentation project. Let's just assume in our little mock world, we've gone in and we're going to run this on the production system, right? Usually this would be on some sort of Kubernetes environment, but for the sake of demonstration, we're going to run it within the, just say like on a server so we can understand like what's going on here. So just kind of want to put that into some sort of preference. So what we're doing here is we actually have a CLI. The CLI is itself just going to be a Go binary. That Go binary is built the same way any other Go binary is built. And then we're going to go ahead and we're going to run this. So when we run this, we're just going to step through this really quick here. What we need to do is in this, we're going to tell it the endpoint, and that's that Jaeger endpoint that we were looking at. The Jaeger endpoint that we were looking at earlier. So we want to make sure that we're sending all of this telemetry to the same endpoint. Otherwise, it wouldn't, that doesn't make any sense otherwise. We're also going to tell it what we're instrumenting. We want to instrument the user service. So that's going to be the path to the binary over there. Next, we're also going to tell it the service name. So we want to tell it what service is actually being instrumented here. The last thing is that we're going to need to run this with permissions. And we'll talk about that at the end.
I think we need to make it bigger, right?
Yeah, should I make it bigger? Is this helpful? Okay. Okay, so if we run that and then remember our password, it goes ahead and it starts up, and then it starts digging through the source code. And what it's actually going to do is it's going to load our auto instrumentation here. So in theory, this should be running, right? So we should be able to come back here, maybe run our endpoint a few more times to get some more errors, get some more traffic through the service. Go back to our Jaeger UI here. And we're going to look for some more of those traces, and they're going to all be coming from that front-end service. I think this is old. Let's update. Well, here we go. Okay, so we got some more errors here. This is probably an interesting one, right? And yeah, look at that. We now have spans for our user service here. This is pretty great, right? All we had to do was run a different binary alongside our already compiled binary. I didn't have to look at the source code. I didn't have to redeploy this. I honestly didn't have to decompile anything. Like, it just ran alongside the existing binary, and we're starting to get spans. We can definitely see through this that we're getting spans that are what we were expecting. Some sort of endpoint that HTTP GET is now connected to a server. And then within that, we're also getting some sort of database lookup. So this is pretty helpful. Like, we figured it out. Like, there's an error and it's in the user service. It's not in the front end at this point. So if we go back over here, let's jump through what we actually just did in the auto instrumentation agent itself, right? Obviously, it's really easy to go and run it, which is by design. Hopefully, that's as easy for you as it is for us. But let's jump through what it actually is doing here. So that auto instrumentation agent, it has a few different components. The first one is going to be an analyzer. So we pass it that Go binary location, right? In that location, it's just going to look through your proc system. It's going to find some sort of executable that's already running, and it shares that particular binary path, right? Once it finds that, it knows that that's the binary that you're trying to target. It's going to look within the actual compiled code binary that's on the system. It's going to look at a lookup table, and it's just going to try to find a function that it knows about. It's going to see like, hey, I know this binary is going to run something with HTTP or with the database or something like that. So I can add, instrumentation for that. Okay, so that's good. I'm going to actually load the instrumentation for that. So what it's going to do then is it's going to send all that information to what we call the manager. The manager is going to make some sort of setup to actually run this eBPF. In that process, it makes a syscall to this eBPF system. It's going to pass in particular probe data for the actual code that we want to run within eBPF. That eBPF code is going to be run through a verifier. It's going to run then through a just-in-time compiler, which is going to transmute it into eBPF code that can actually run within the system. So here's our target process over here. Now that we have this code in the eBPF system, we need to actually have this probe be triggered by our system or by our executable. So what that looks like is we're actually going to update the binary on the system to have a breakpoint. That breakpoint is going to, when the code is run, be triggered. It's going to have some sort of trap that comes back to the eBPF program that we had already preloaded. The eBPF program is going to run and do all of the nice things that we were looking at in generating the telemetry, getting attributes, and understanding some sort of context so it can link the spans appropriately. It's going to send that back through eBPF maps and then hand it back up through the manager. The manager is going to be the place that's going to also receive information from the eBPF system. All that eBPF data that's passed back to the manager needs to be translated into some sort of OpenTelemetry format. To do that, the controller exists. It's going to do some quick processing, and it's going to turn into a standard also defined by OpenTelemetry called OTLP, and it's going to send it to our endpoint, which was what we just saw, right? All that with just one command, right? That's pretty good. I think that's pretty good. So we're all done, right? Mission accomplished. This talk is really short, and there you go. So I think not, right? I think all of you are very good SREs, even though maybe you weren't at the beginning of the talk. I think you are really good SREs right now. And I think you're going to go the extra distance, right? Because Alice is a really good user, and let's see if we can actually find some more information, right? What we've seen here is we know that our error is coming from the user service, but all we can tell them is that it's coming from the user service, and we're going to pass it off to that team at this point, right? Alice is paying us a lot of money. Let's see if we can find out a better understanding for this and try to fix this a little faster for her. To do that, we need to talk a little about interoperability, right? So we talked about two different forms of instrumentation before, and maybe we can do a little better job in producing something more similar to this. So what we had before is just this span above, some sort of HTTP request, and some sort of database lookup underneath, right? What we really want is some sort of span in the middle saying like, hey, here's the thing that's actually generating the error and maybe some context about the error. We're going to use these attributes to tell us not only that it was an error, but what that error was and maybe give you some information for it, right? I think that's really what we want. If we have that, then we can go back to Alice and say like, not only do I have a solution for you, but I have a fix because I know how to solve these errors, hopefully. And so, yeah, that's kind of the goal at this point. I think I hit the wrong button. Okay. I did not hit the wrong button. I jumped ahead. Okay, so let's do that. Okay, back to advanced mode, I guess. Okay. So to do that, what we can do is we can go back to our auto-instrumentation. Man, I am lost at this point. I'm usually not that bad. Over the shoulder stuff is a little bit of a challenge. Okay, yeah, perfect. Okay, I see where we are. So what we're going to do is download a version of the user service, and we're going to try to get some sort of setup from production, right? We're going to try to do some sort of manual instrumentation here to augment and extend what we already get from our auto instrumentation. We're going to run into some sort of sandbox environment unless you really don't like your job and you want to get fired, and we can go run this in production. But we're going to try to download this and do this locally, right? And so what we're going to do is we're going to try to find some sort of user service, and we're going to pull the source code at this point. And we're going to go the extra mile by looking at the source code. It looks like there's some sort of server here, and we know that from the server there's some sort of issue. So let's jump in there. Jason, can you see this in the back? Okay. Okay, so now we're in our user code, right? Which is what you've all been waiting for. You're all a bunch of Go devs, right? Like this is where you live, right? So what we can do is we can start mixing in some manual instrumentation at this point, right? So to do that, let's start by importing the packages that we need. Let's go ahead and create a tracer. That tracer is the thing that's going to be the thing that starts and ends spans and connects them all into a particular trace. So conceptually, that's what a tracer is doing here. From there, we're going to actually start our span. That span is going to encapsulate some sort of functional element within our server request handler here. Handler alloc is the actual method. And what that's going to do is it's going to try to encapsulate something where there's a possible error, right? Like this is a pretty straightforward pathway for what the code is doing. We can see right now that we have just path parsing. We know that we're actually opening up a database connection, and then we're calling out to the database connection, and then we're responding with some sort of JSON. So let's see if we can have that span capture the thing that's actually calling out to the database, because we know somewhere between handling and actually responding, there's some sort of error, right? So from on top, once we create the span, we're going to end it. That's kind of important. But this is kind of the key thing that we were looking for, right? This is where we're adding all that data. So what we're going to do is we're going to set the status of the span, and we're going to include within that status the error information as a message up through the code base. So this should actually generate what we were looking for, right? That whole holy grail span with that annotation that we actually want, right? Okay, so that should be it, right? We're going to save this, and we're going to run it, and it should be good. So who here has run OpenTelemetry before in the wild? Okay, I got one person. Do you remember that PR we looked at before, right? With 200 lines of code, right? That was not 200 lines of code, right? So shouldn't work, right? This should probably fail at this point because like we need 196 other lines of code, I guess, right? But let's give it a try anyways. So let's build this. There we go. And if go ahead and rerun it. Looks good. Now let's restart our auto instrumentation here. In the process of restarting it, though, there we go. We're going to need to change one thing, and that one thing is that we're going to need to tell it to interop with the manual instrumentation. And to do that, all we need to do is pass this flag for the OTelGo auto global. And what that means is that it's going to interop with the global implementation for the default of OpenTelemetry, right? So let's try running that. Okay. Cool. So it looks like it starts up. And if we step back here, like we can also see, maybe if we jump through this, like we can start seeing that like it's loading all the things in the analyzer that we were talking about before. We can also see that it's loading probes. Particularly one of the things it's doing, oh, I just had it. I swear this over the shoulder is the hardest. But we can see like it's already investigated and it's looked inside the particular process ID that we've looked at, and it's found all of the different libraries that we're using. It knows that particular libraries that we're using are some things that it actually knows about, some things it doesn't have that it knows about as well. And then it's loading, and then I think those are all the, and then it's loading the appropriate instrumentation for those libraries. And then, yeah, successfully starting. So we can also see that spans are starting up. So let's go back and see if we can find some more information. Let's jump in here and regenerate some errors. There's one. Looks good. Jump back to our Jaeger service now. Let's find some new traces and maybe cross our fingers. Yeah, this may be it. There's definitely 3 in there. Okay, look at that. So this is the magical span we were missing, right? This is, I swear, if you can tell from the presentation, I'm not that good at slides. So like, I really did copy paste that, but this is what we were looking for, right? This is live, right? We have some sort of error here. It's that user quote or span that we were looking for. It's telling us that the status description is the database table is locked for the users, so that's not good. Which is phenomenal, right? Like now I added 6 lines of code. I have way better understanding of what was going on with the error. Do a really quick Google search, right? And I should be able to find that this is a pretty common error for some sort of SQLite interaction. So just to kind of step back, like before, what we were going to do is we're going to tell Alice, yeah, everything's great. Also, our user team, who just all started on vacation, they'll be back next week and you'll get an answer then, right? So now what I can tell her is, actually, I know what the error is. This is great. And I know since it's a common error, there's a common fix for it. I've not only found your error, I've submitted code and it's going through our release process. It should be out in, I don't know, however long our release process is. So forever or in 5 minutes. Anyways, so like that's a way better story. And all I needed was more instrumentation at this point, right? So how was I able to do that? It was all through that interoperability, right? And so that interoperability allowed me to take something that would have taken on the order of 200 lines of code down to, I don't know, is that even 6? I guess, yeah, okay. With the imports, like that's a few, right? But this is also, you know, just to kind of step back, like you can talk about numbers, right? But think about more the journey now that they're on. When I'm going to submit this to the user team, I'm going to submit not only some sort of fix to a bug that they have, but I'm going to submit the first steps that they will have in their journey for observability. This is going to include code that is going to start their auto-instrumentation, but also their manual instrumentation journey. They're going to have better observability into their service at this point. They aren't setting up an SDK. An SDK is normally the thing that backs it. Normally, the auto-instrumentation is not going to be there, so you aren't going to get this span generation. And OpenTelemetry is designed by default that this won't add any overhead. This is not something that is going to impact their code or the processing, and it's just going to act as a no-op when it's not there, right? So yeah, this is a phenomenal user story here. As a developer, which I think a few of you are, right? This is a way better thing for you to get a ticket on. Not only like somebody coming to you and saying like, hey, I have a problem, but here's the solution that I've come up with, and maybe you should also fix it because I don't know really what I'm doing fixing this, but here's also a way to start this, right? I think this is great. I've worked in both roles, and so yeah, I definitely think this is great. Okay, so that's the kind of the big overview of auto-instrumentation for Go, right, in this service. There's definitely some challenges. One of the things that we have to do is we have to run this with sudo. That's because we need to actually write to that user context. We were talking about distributed traces in that context that's shared between services. From the kernel, I need to write back to user space. And to do that, like the eBPF provides that functionality, but it's an elevated privilege for now. We are looking at alternatives for this. This is not the end of the story. This is a new product, but like a new part of OpenTelemetry, but we are still actually trying to fix it, so that's not going to be the case. Anybody go to KubeCon by chance? Okay, I see one hand. If you don't, I think the recordings will come out from the North America one, and they're going to have a talk, hopefully, not myself, but another co-maintainer is going to have a talk kind of explain how we're going to be fixing this. Another thing is that there's definitely, remember how we were talking about breakpoints. The breakpoints can cause a little bit of overhead in the context switching between user space and the kernel. That can be an important thing to consider if you're looking at high performance systems, but you also have to consider that we're doing all of the telemetry processing in that controller and it's out of band. So there's a lot of trade-offs here to keep in mind. That one is something also that you can improve with maturity and people contributing to the project and improving it, people like you. So with that said, the roadmap for this project, we are still not at a place that we're GA. It's definitely not stable. We're still working on it. We're definitely looking at a lot of improvements, both functionally as well as performance-wise. We are looking to get to a stable point and offer something that is going to be something we can provide support for years to come. So that's important. We need to also stabilize that semantic convention support. One of the things that I kind of just glossed over was that we were getting spans that showed up with that error little button, right? That was pretty great, right? I could just find those errors really quick, right? That's from semantic conventions. That was the thing that I was kind of harping on, those standards, and that's really important to have there. So we want to make sure that we are compliant with the standards from OpenTelemetry as we're releasing this. I talked about the alternatives, the eBPF road, right? We also want to support more libraries. Right now, we support NetHCP, gRPC, Kafka Go, Database SQL, and OTel, which we showed as the interoperability for OpenTelemetry. OTel is the shorthand for that. And then on top of that, we only were talking about traces. got a lot out of traces today, right? We solved this problem, but we want to look at metrics and maybe logs as well in the future. So these are things that we're planning to look at. Cool. All right, so that's going to be the end of the talk. I definitely want to point out that here's the repository. You all now have enough context to go contribute to this. Maybe not the internals of the C program, but maybe the internals of the C program. We would love contributions. Any sort of uses of this, we would love to have issues that you have any sort of bugs. Honestly, even if you show up to our what we call meetings for the group and just share your experience, we find a lot of value in that. So just contributing, it's open source. Open source is defined and run by people like you and me. So we want that sort of contribution. If joining a meeting or opening a PR is a little bit out of what you want to do, we have a Slack channel on the CNCF Slack. And so, yeah, you can find us all there. Thank you.